Okay, once again, good morning. In the last class, we have discussed the isometric projection of the pyramids. Two pyramids we have discussed, that is a square pyramid and the rectangular pyramid. Okay, so today we'll discuss three more exercises. So, that is, let me take up this pentagon pyramid. So, what is the question which is given? Draw the isometric projection of the pentagon pyramid of side of base 30 millimeter and axis side 60 millimeter when its axis is vertical. So the pentagon pyramid, when it is seen from the top side, it look like an pentagon. First, you in the top view, you construct the pentagon, the corner condition or head condition, any condition you can the construct, and it's a regular pentagon 30 millimeter. You know how to draw the pentagon. So you name it as so here I named it as ABCDE. Then as usual, so enclose the pentagon within the box. From E you draw horizontal projector on either side. From D you draw vertical projector on either side. From C you draw horizontal projector on either side. And from A or B you draw vertical and horizontal vertical projector on either side. So wherever these projectors meet, okay, your box is ready. So I'm taking this box as the LMNK. So I've named it. You can give your own name. Okay. So afterwards, when it is seen from the front side, it look like an, say, what you have to do for to draw the front view, draw the vertical projector from all the three points, and find out the center also from the pentagon. So how to get the center of the pentagon? So you have to bisect any two line to find out the center of the pentagon. How to draw it? So for example, from A to B, more than half you take and draw an arc from A as well as B. Similarly, from any other side, from A to E, take say more than half of the from you with the help of your compass. Cut it from A to A as well as E. So with that intersection, so here whatever the intersection, the arc you are getting it, you draw a line to this corner, and here whatever the intersection after bisecting this AE you are getting it, you draw a line to this corner. If you do this, so wherever this and this line intersect, so that is your the center of your pentagon. So like this, you have to find out the center of the pentagon. From the center of the pentagon also you draw a vertical projector, because center of the pentagon means so where the axis line at the center line of the pyramid exists. So after drawing the vertical projector from all these points, from the axis line at the center point, you take 60 millimeter and draw the vertical projector line. Okay, from this is your vertex or the apex. Now you draw a line like this to all the points. Okay, then the front view of the pyramid is ready. That's all. Okay, after this, so let me start the isometric position. First, I will draw the isometric position for the base of the pyramid, and then so we'll complete the pyramid. So as usual, so you take any one horizontal line right side like this. Take any one of the point. I'm taking the point as L and draw 30-degree line on either side like this, and from L to M and L to K you take the distance and convert that into isometric the scale. So here in isometric position, whatever the dimension that you will draw here, so in the isometric the section, it has to be isometric scale only, not the actual scale. So L to M you take, convert that into isometric scale. From L, right side of the 30-degree line you cut it, you call it as M. Similarly, L to K distance you take, convert that into isometric scale. From L, you cut this 30-degree line left side of you, and you call this as the K. Once you get this K and M, from K you draw a parallel line to LM or draw 30-degree line right side. Similarly, from point M here, just you observe the cursor, draw a parallel line like this to LK, or else draw 30-degree line left side. Okay, so wherever these two lines intersects, you call that as the point N. So the outer rectangle you have drawn the isometric projection. Now we have to identify the pentagon points A, B, C, D, E, and we have to join it. So then your the base of the pentagon is ready. So K to A and L to B distance is same. You take the distance, convert that into isometric scale. From K to here you cut it, from L to here you cut it. AB you will be getting it L to C this distance, and K to E distance also same distance. Okay, no need to take twice. So convert that into isometric scale. From L you cut this, you will get C. From K you cut this line, you will get E. So after this, D either from M to D, N to D, it's exactly at the midpoint. You take any one of this distance, convert that into isometric scale. From N or M, you cut this. So you will be getting A, B, C, D, 5 points. You will be getting it. Now you can join this 5 points A, B, C, D, and E. So this is the base of your pyramid, that is pentagon pyramid. So after this, after constructing the base, we have to find out the center of the base here also. So how to find out the center of the base here? You draw the diagonal for the outer rectangle from K to M as well as N to L, like this. You can draw the like this, two lines N to L. It is not N to B. Okay, N to L you draw one the line, and K to M you draw one line. That is the diagonals. You draw the diagonals K to M and N to L. So wherever it intersects, it intersects, so that is the center of your pentagon. See, this is the intersection line. So this is the center of your pentagon. From the center of your pentagon, you draw a vertical projector like this. You draw a vertical projector like this, and this vertical projector line, you take isometric 60 because that is the height. You take isometric 60 and cut it. So that is your apex point or the vertex point, called that as the O, and your base point, so base center point, called it as the O1. So this is the vertex, means all the corners of the pyramid. What it says, once you find out the vertex or the apex, all the corners should be joined to your vertex. So from A to O, B to O, C to O, D to O, and E to O, you join it first with a light line only. At the end, you can make it the visible edges and hidden edges. And for axis line, that is center line, so we have discussed during our basic classes the types of lines. Okay, so on continuous line, on dot, on continuous line, on dot. So that is the representation of the axis line. So after joining all the lines with a light line, finally you need to darken only the visible edges. Visible edges in the sense, the always, so we have to highlight, or we have to draw the visible edges only to the outermost boundary edges, or outermost the boundary lines. So the base of the pyramid is concerned 1, 2, and 3. These 3 base edges you can see. You cannot see this and this base edge. You put it in the hidden edges, as a hidden edges, dotted edge, or else, so you can remove it. Not an issue. Next, coming to the other slant edges, from here to here you can see, from here to here 4 slant edges you can see. You cannot see this slant edge which is behind you. So this completes the isometric version of the pentagon pyramid. That's all. So we'll go to the next one, hexagon. So in this hexagon also, the procedure that we have to follow, it is almost similar, only here 6 sides we have to consider, that's all. So what is the question is given? Draw the isometric version of hexagonal pyramid of side of base 40 millimeter and axis height, and axis height is 60 millimeter is given here. Okay, so here also you construct the hexagon, either its condition or the corner, because the hexagonal pyramid, when you see from the top side, it look like the hexagon only. So that's why you draw a hexagon. Either edge condition or corner condition, it's left to you. So I have taken the edge condition, I have drawn it. So I am naming this the hexagon as the 1, 2, 3, 4, 5, 6. I have named it. And before starting my isometric projection, let me enclose this hexagon within the box. So from 3 you draw horizontal projector on either side. From 4 or 5 you draw vertical projector on either side. From 6 you draw horizontal projector on either side, and from 1 or 2 you draw vertical projector on either side. So wherever these projectors the intersect, so that is the square inside whatever you are getting it. So your outer square, I am calling it as PQRS. So now when the hexagon pyramid, when it's seen from the front side, it look like a triangle here also. So what you do, So you draw the vertical projector from all the 3 points like this. Okay, and then this is the center. Okay, from here you take 60 millimeter height. After drawing vertical projector line, this is your apex or the vertex. Now you join on either side of the corner, so it look like an isosceles triangle only here. Okay, so this is your front view. Now let me start the isometric projection of the hexagon pyramid. First I'll draw a horizontal projector line like this, and I identify any one of the point. I'll be calling that point as the P. Now I'll draw the 30-degree line on either side of this point like this. After drawing this 30-degree line on either side of this point, so I'll measure P to Q distance and convert that into isometric scale. From P, I'll cut this right side 30-degree line. Okay, and I'll call that as the point Q. Similarly, I'll measure a distance P to S and I'll convert the distance into isometric scale. From P, I'll cut the left side of the 30-degree line and I'll call that point as the S. After getting this S and Q, from S, we can draw a parallel line to PQ like this, or else 30-degree line right side. How to draw 30-degree line? Just draw one horizontal line here, and then you can take 30-degree line and you can draw it. Similarly, from Q, you can draw a line like this parallel to PS or 30-degree line left side. This 30-degree line left side, you can draw a diagonal for your reference. S and Q you can join, and then 30-degree line you can draw it in this direction as well as 30-degree in this direction. So whichever is easy for you, you can do that. Okay. So wherever these two lines intersect, you call this intersection as the W. So my outer, so P, Q, R, this is R. Okay, you call it as R. So after this, we need to identify these hexagon points. So what to do for this? So first you take this distances P to 1 and S to 1, S to 2, R to 4 and Q to 5. All the 4 distances are same. You take any one of the distance, convert that into isometric scale, and from P you cut this line, call it as the 1. From S you cut SP line, you call this as the 2, and from Q you call this QR line and call this as the 5, and from R, this is not W, it is R. From R you cut this line, you call this as the 4 points, so you will be getting it. So how to get 3 and 6? So you take, this is exactly the midpoint between S and R. Either you take S to 3 or 3 to R, or P to 6, 6 to Q. All the 4 distances are same. You take any one of that distance and convert that into isometric scale. So after this, from S you cut this distance, call that as the C. From P you take same distance, cut this, you call it as the 6. So all the 6 points you'll be getting it. Now you join these 6 points, 1, 2, 3, 1, 2, 3, 4, 5, 6. You will get the isometric position of the base of the hexagon pyramid. Base is ready now. So now, how to find out the center of the base? Now you join the diagonals SQ and RPR. These two you have to join and find out the center like this. See, SQ and PR you can join wherever it meets. So that is the center of the base of your pyramid. You can call it as O1. And from this center of the base, you draw a vertical line like this. You draw a vertical line like this, and then this on this vertical line, you take what is the height of your hexagon pyramid? It is 60 millimeter. You take ISO 60 from the center on this vertical line and cut it. So once you get this point, so this is your vertex or the apex. You call that as the O. And now after finding out this apex or vertex, you need to join all the corners. So O1, O2, 2, O2, 3, O2, 4, O2, 5 and O2, 6. Like this, all the corners of your base of your pyramid should be joined to your vertex after finding out the vertex. So once you do this, almost your the isometric position of the hexagon pyramid is Done. Only thing is at the end, the visible edges and hidden edges you have to identify how to do that. So you're all familiar with that. So the base edges concerned 1, 2, 3, 4. These are all the outermost boundary lines. You can see this base edge and this base edge. You cannot see. You put it in terms of hidden edges or dotted edge, and the slant edges from here to here. You can see from this, and from this here to here. You can see only these two which are behind you from here to here and here to here. These two, the slant edges that you cannot see, you can mark it as hidden edges. So if you do this at the end, okay, so don't make it the visible edges or the thick line or dark line the visible edges until okay the last the step. Once you complete the projection, then only you do this. Okay, so till that, okay, you need to draw all the lines, the thin lines only and the light lines only. So this is your isometric version of your hexagon pyramid. Okay, so coming to the next one, so that is a cone. So as I told, your cone is also comes under your the pyramid because it's a circular pyramid. Okay, it has got only the thing is it has got the circular, the base. That's all. Okay, similarly we have considered the cylinder under prism. So because it has got two similar the circular faces. So similarly for pyramid, so we'll do it with this pyramid, this cone. So what is the question which is given here? Draw the isometric projection of a cone of side of base 50 millimeter and height 70 millimeter, and its axis is vertical is given. So the cone, so you can imagine your ice cream, the cone. So when you see from the top, it look like a circle only. Okay. When you see from the front side, it look like an isosceles triangle. First, you draw a circle in the top view. The radius 25 millimeter or diameter 50 millimeter. Draw a circle first. After drawing a circle, you enclose this circle within the box. So here you are going to get exactly a square box. So how to do it? From here, from this point you draw a in the horizontal direction. From this point you draw a horizontal projector line. From this point, that means you are drawing a tangent. You draw a vertical projector line vertically. From this point you draw a vertical projector line. Wherever these horizontal vertical projectors meets, so your box is ready. So I will name this box as the 1, 2, 3, 4. And now to draw the front view, you draw a vertical projector from here, from the end point of top view, and from the center, you draw one vertical projector. From here, from the center, you draw an axis line, that is the vertical line, and take 70 millimeter, cut it here. This is your vertex or the apex. Now you join from the vertex or apex to this point and this end point. So the cone will look like an isosceles triangle in the front view. So your both the top view and front view is completed. So next, first I will draw the isometric projection for the base of the your cone first. So then we will draw for the cone first as usual. So draw the horizontal projector like this. Take any one of the point. So I am taking my point as the 1. Now you draw 30-degree line on either side like this for some length. Now it's a square. For circle, so whatever the box that you are enclosing, it is a perfect square of 50 millimeter square you will be getting. So 1 to 4 and 1 to 2 distances are same. You take this distance and convert that into isometric scale. From 1 as the center, you cut right side of the 30-degree line and call that as the 2. Similarly, from 1 as the center, you cut left side of the 30-degree line, you call that as the 4. So after this, after getting 2 and 4, how to get 3? From 4, you draw a parallel line to 1 to 2 or draw a 30-degree line right side. Similarly, from point 2, you draw a parallel line to 1 to 4 or 30 degree, this 30 degree. So 30-degree line left side. Wherever these two lines intersect, that intersection point you call that as the point 3. So the outer square or the box, so we have constructed the isometric projection. Now within this the box, we need to construct the ellipse because the circle will look like an ellipse in the isometric the projection. So how to draw the ellipse? This is the third time we are drawing, third or fourth time we are drawing this ellipse. So how to do it? It's a 4-center method. How to do this? So this 4 to 2 you have drawn on diagonal. You have joined 4 to 2. After this, how to get the 4 point? From point 1, before doing this, 1 to 4, 4 to 3, 3 to 2, and 2 to 1, you find out the midpoint or the center. Exactly the center point you find out and mark it. So after that, from point 1, you draw a line to midpoint of 4, 3 like this. Similarly, from point 1, you draw a line to midpoint of 2 to 3. Okay. Similarly, from point 3, you draw a line to a midpoint of 1 to 4. And similarly, from point 3, you draw a line midpoint of 1 to 2. Like this, 4, the lines, construction line you are drawing it. So it's a 4-center method. How many center you will be getting is 1 is 1 center, 3 is 1 center, and this intersection. This and this intersection is your one more center. Total 4 centers you will be getting it. Now how to draw the ellipse now? So from point 1 as the center, either this or this as the radius. Okay, you take that distance from point 1, you construct the arc from here to here. Similarly, from point 3, from 3 to this midpoint, from 3 to the same. You take this distance from your compass, this as the center, you draw an arc from this point to this point. So 2 arcs you have constructed. Now from this intersection, this is the third point, either this or this as the radius. Okay, from this point you construct an arc like this from here to here. So now the fourth point is this intersection. From this intersection point, either this or this as the radius, you draw an arc in this fashion. So after drawing all these 4 the arcs, you will go to get a perfect ellipse. So this is what your ellipse. So this is the base of your the cone. This is the base of your cone. So after the completion of this, how to find out the center of the cone? So to find out the center of the cone, what you have to do is, so you need to draw the diagonals, both the diagonals, 3 to 1 and 4 to 2 diagonals you have to draw wherever it intersects. So this O1 is the center of your base of the cone. So this intersection you call it as the center of your the ellipse, and from this center you draw a vertical projector like this. You draw a vertical projector like this, and on this vertical projector line you take isometric 70, not the actual 70. Okay, you take isometric 70 from this O1, you cut this vertical line. Wherever it cuts, then you call that as the O, that is the vertex or the apex of your the cone. After getting this vertex or the apex, because in the cone we don't have any corners to join, and even similarly in prism also, in cylinder also, so we have done the same thing. We have drawn the tangent there, correct? So here also the base of your cone doesn't contain any corner in this case. So that's why what we have to do is, we need to draw a tangent from apex on either side. From O, you draw a tangent to this the ellipse left side, as well as the draw a tangent from O to this right side of your ellipse like this. So this completes your isometric position of your cone. Now at the end, so we need to draw the visible and the hidden edges. See, you can see like this. So if you tilt the cone like this, one half of your base you can see, the other half of the base you cannot see. So that's why this is inside. So that's why this half of the cone we have to highlight with the help of the hidden edges that we cannot see. And this tangent from the vertex or the apex we can see like this. So in isometric projection, the cone will exactly look like this. So this completes the isometric projection of the pyramid. Also all the pyramids that we have discussed. So as of today, what are all the things that we have